Manual acquisition. The GEMO Raman can be operated even in manual mode. The autoscan procedure includes all the steps needed to automatically identify the stone under testing. All these steps can be even performed manually, and very often there are good reasons for doing that. The more common situation occurs when there is no need for the operator to go through all the phases included in the autoscan feature. By running them singularly can save time, and this can have an impact on the workflow, especially if a number of stones needs to be tested. Another reason for going through the procedure manually could be to check if the stone can be identified by Raman spectrum, or it will be more suitable to run for PL spectrum. We will cover the PL feature of the GEMO Raman in a specific video. Pre-scan. The purpose of the pre-scan is to find a more appropriate exposure time for acquiring the best possible quality spectrum. Strange level Raman or PL signal of each material can vary substantially, and a more accurate spectrum is achieved by selecting the total exposure time accordingly. The pre-scan finds the best exposure time by summarizing consequent short-step measurements until the strongest Raman or PL peak of the material is near the maximum of the spectrometer's capability. Despite being not very accurate, the pre-scan spectrum gives already an idea of how the final result will look like. There are many cases where the operator needs to simply discriminate between 2 or 3 possibilities, and hence the simple pre-scan alone can solve the issue, saving lots of time. This procedure is particularly useful when evaluating the consistency of parcels of stones. Click on the pre-scan button. Before proceeding with the pre-scan, the software needs to know what type of scan the operator needs for. The GEMO Raman can acquire Raman and photoluminescence spectra, and the pop-up window features the 2 choices. Let's select Raman spectrum now. We will cover the photoluminescence feature in another video. The laser will now illuminate the stone, and a countdown will ensure the signal to have the best suitable intensity for the measurement. After the pre-scan has ended, 2 features will be displayed on the screen: the exposure time and the number of averages. These 2 parameters are automatically calculated to be the most appropriate for providing the best Raman spectrum. DARScan. Click on the DARScan button. The purpose of the DARScan is to measure the noise of the spectrometer for each CCD channel. This is the signal the spectrometer detects in total darkness. It's a built-in feature for all CCD type light sensors, and it must be reduced from the actual measurement signal in order to achieve the best possible spectral quality. Full scan. Click on the full scan button. The full scan step is the actual spectrum acquisition of the sample. It is performed multiple times and averages just like the DARScan for a better signal-to-noise ratio. The spectrum of the sample is shown in the small window during the full scan process. Since the DARScan and the full scan are very often performed in sequence, the software provides the dark and full function, which include them both. Now the scanning procedure is completed and the whole Raman spectrum is displayed on the screen, but before to be suitable for comparison against the spectral database, it needs to be trimmed to the fingerprint zone and then manipulated by performing the background correction. Trim to fingerprint zone. Click on Trim to fingerprint zone button. This step will select the fingerprint zone of the Raman spectrum for allowing its comparison against the spectra of the database. Background correction. Pure Raman spectra consists of sharp peaks located on a flat baseline. In other words, the wave number locations where the material has no Raman peaks should give 0 count, complete darkness. This ideal situation is often disturbed by luminescence reactions such as fluorescence. The resulting spectrum is of mixed type, sharp Raman peaks riding on top of more broader luminescence bands. The purpose of the background correction is to try to estimate the slope effects of luminescence and subtract them from the spectrum, leaving the Raman fingerprint as much pure as possible. Search in the database. Once corrected to the baseline, the spectrum is now ready to be compared against the spectra included in the database. The software will perform the search and report the result. A number of samples will be listed, starting from the one matching most closely to the analyzed sample. In conclusion, the purpose of operating manually instead of using autoscan is essentially to save time in those cases where the operator has already a clue about the possible identification. There are several instances where a simple glance at the pre-scan result can solve the issue, so there will be no need to waste time for a complete scanning procedure. Practical examples. Let's see a couple of cases where the single pre-scan procedure can solve the issue. As you can see from this image, Diamond has the most simple and easy to remember Raman spectrum, consisting of a single peak centered at 1332 cm-1. All its simulants have completely different Raman spectra. Running the simple pre-scan is enough to identify a diamond in a matter of few seconds. The single peak is clearly visible here. But what about color stones? It's a simple case. The operator is guessing if this stone is a topaz or a citrine. Let's run the pre-scan. Quartz has a very distinctive Raman spectrum dominated by a major peak at 464 cm-1. So let's search for the citrine spectrum in a database. Even without remembering the exact location of the major peak of quartz, we already realized this stone has a quite different Raman spectrum, so it's not a citrine. If we want to have a confirm, we can browse the spectra from the library and check topaz. Even if the pre-scan result is not clean, the resemblance is quite obvious. Of course, for the correct identification, the complete procedure should be performed.
Thank you for watching this video. For more information about our spectrometers, please visit our website. And if you have any question, please don't hesitate to contact us at info@gemoraman.com.